Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 13. This is solving quadratic equations by completing the square. So in Lesson 11, we completed the square of quadratic expressions where a was 1. In Lesson 12, we completed the square of expressions where a was something other than 1. And so now we're going to solve quadratic equations using the quadratic, or completing the square. So a says solve the equation for b. So we have 2b squared plus 9b minus 9b equals 3b squared minus 4b minus 14. Okay, so when I solve these, I do not want my leading coefficient negative. So if I subtracted 3b over to this side, I'd get 2b squared minus 3b squared, which is a negative b squared, and I don't want that. So I always move the smaller of the two. So I take minus 2b from this side and minus 2b squared from this side. These cancel, and I get negative 9b equals 3b squared minus 2b squared is 1b squared, or simply b squared, minus 4b minus 14. Okay, so now I'm trying to get this equal to 0. I want all my b's on one side, so I add 9b to both sides. Line up your like terms. Do not put this under the squared. These cancel, and I'm left with 0. Negative 9b plus 9b is 0. b squared just comes down. Negative 4b plus 9b is positive 5b minus 14. Okay, so now that I have a quadratic, or an equation equal to 0, I now want to complete the square. Okay, but instead of completing the square, I can look for factors of c that add up to b. And I'm going to write that. So let me type it. Okay, so there's my little rule there, factors of c that add up to b. That's just how I get my students to remember this. So remember that if we have ax squared plus bx plus c, c is my constant and b is my linear coefficient. So when I take factors of c, that's factors of 14. Or actually it's negative 14, factors of negative 14. And that means one's positive and one's negative. So it could be negative 1 times positive 14. It could be negative 2 times positive 7. It could be positive 1 times negative 14. And it could be positive 2 times a negative 7. And I'm going to add these factors of c that add up to b. So if I add these, I get 14 plus negative 1, or 13. Negative 2 plus 7 is 5. 1 plus a negative 14 is negative 13. And 2 plus a negative 7 is negative 5. Okay, so I want these to add up to b. And b is right here. b is my middle term, my linear term 5. And obviously, that is what adds up to 5. So this is going to be 0 equals b and b, and then I'm going to put minus 2 and plus 7. Okay, so we have in math what's called a really important property called the zero product property, which states that if you multiply anything by 0, you get 0. So if this were 0 and this wasn't, it would still equal 0 because 0 times anything is 0. If this one was 0, this parentheses was 0, and this wasn't, 0 times anything is 0. If they're both 0, then 0 times 0 is 0. But they both can't be 0 if these numbers are different. Okay, so now to finish this, I need to take each of those factors and set them equal to 0. So I get b minus 2 equals 0, or b plus 7 equals 0. And to solve this, I add 2 to both sides, and b negative 2 plus 2 cancels, equals 0 plus 2 is 2. So b can be 2. That's a b. or subtract 7 from both sides, and b equals 0 minus 7, which is negative 7. So b equals negative 7 or b equals 2. All right, next problem. It says to rewrite the expression by completing the square. 1/2 b squared minus 4b plus 13. Now remember from the prior lesson that when we have a not equal to 1, we want to write that outside of the parentheses, or I like using a bracket. And I'm going to put my b terms inside, and I'm going to leave that for now for a reason because of that. And I'm going to put my constant outside. So the plus 13 goes here. 1/2 times b squared is 1/2 b squared. So that's good. But I need a number here that will give me minus 4b when multiplied by 1/2. And, or I could just say negative 4 divided by 1/2 is the same as negative 4 times 2, which is negative 8. 1/2 times negative 8 is negative 4. Then that is my middle term, or my b term, and from the prior two lessons we remember that we divide it by 2 and square it. So I'm going to take this and square it. It's going to equal 16, but I'm going to write it as plus a negative 4 squared, just so it stands out. All right, so, and if you watch my video for lesson 12, then you know why I'm doing this color coding, because we have 1/2 times a negative 4 squared that's being added in. So therefore it's no longer equal to our original until we subtract the same thing. Like so. So these two red items are opposites, or additive inverses of these two. And they cancel out to 0, making this expression equivalent to this one. Okay, so now I know that I have 1/2 parentheses b squared, and it's this term here that I didn't square, and that's why I didn't square. It's staring me right in the face if I leave it as something squared. And then we have plus 13 minus, and negative 4 squared is 16, times 1/2 is 8. And then finally, it's 1/2 b minus 4, quantity squared, and 13 minus 8 is 5. And we have rewritten the expression by completing the square. Okay, here's example 1. It says solve for x. Now remember, we're completing the square. So I'm going to leave this constant over here, and I'm going to complete the square on the right. So I need a number over here to make this a perfect square. Here's my b term, and we divide it by 2. And it's 3. And we square that, and we get 9. So I'm going to put plus 9 here. But if I add 9 to the right, I need to add 9 to the left to make it still true. 9 plus 12 is 21, equals x squared plus 6x plus 9. Okay, so now I'm going to solve this by completing the square. So 21 equals x plus, and here's my b right there, that goes there, squared. Okay, so now I have a quantity squared equal to a number, and the inverse operation of squaring is taking the square root. So I'm going to take the square root of both sides, and that's going to leave me with x plus 3 equals the square root of 21. And then I'm going to subtract 3 from both sides, and I get the square root of 21 minus 3 equals x. Okay, now I'm in the habit of doing this. I have to keep in mind that I only did the principal root. And what that means is whenever we take the square root of something, we can get a positive or a negative out of it. Okay? So when I put this plus or minus here, then I'm just going to fix this. I'm going to say x equals, and I'm going to put my constant first, negative 3 minus the square root of 21, or x equals -3 plus the square root of 21. And that is my answer. Okay, that brings us to page 2. And we're talking about rational and irrational numbers. And it says here, now keep in mind what a rational number is. Okay, look at the root word for rational number, ratio. And a ratio is a number divided by another number. Okay, a comparison of two numbers, if you will. It's a ratio or a fraction. All right, so in other words, 3 over 1 equals 3. It's rational. 1/3 equals 0.3 repeating forever and ever. It's rational. So an irrational number is a non-repeating, non-terminating decimal. Examples that we will be seeing in this lesson of irrational numbers are square roots of non-perfect squares. The square root of 1, let me clean this up a little. The square root of 1 equals 1. The square root of 2 equals, and I'll just get my calculator. The square root of 2 is 1.414213562. That does not stop here. It goes on forever and ever and ever and ever. Okay, so I'm just going to do an approximate symbol and say 1.4, what was it? I like going out 4 decimal places. 1.4142, roughly. Okay, the square root of 3, irrational. I'm not going to keep doing this. The square root of 4 is 2. The square root of 5, square root of 6, square root of 7, square root of 8, irrational. Square root of 9, rational, 3. Okay, so that's just talking about square roots of perfect squares being rational, and square roots of non-perfect squares are irrational. Now it says the sum or product of two rational numbers is always a rational number. Okay, 3 times 5, 15. All three are rational. Every time you have two rational numbers, you multiply by another rational number, you get a rational product. The next one says the sum of a rational number, how about 4? The sum and an irrational number plus the square root of 3 is always irrational. Since this is irrational, adding 4 to it still makes it irrational. In other words, clear, square root of 3 is 1.732050808, and it goes on and on and on, and then I add 4 to that, and now it's 5.732050808, and goes on and on and on forever. Okay, so the sum of a rational and irrational is always irrational. Okay. 3, the product of a rational number, 4, times an irrational number is an irrational number as long as the rational number is not 0. So 0 is rational because 0 times the square root of 3 is a 0 product property. That would equal 0. But any other number besides 0 that's rational times a radical or an irrational number is going to be irrational. Alrighty, so that's just recapping irrational and rationals. And now we're moving on to example 2, and it says to solve for x. Alright, so first thing I'm going to do, first thing you always should do is look for a common denominator, or I mean a common multiple. Greatest common factor. I'll get that straight eventually. Greatest common factor. So I know 4 goes into 40 10 times. 4 goes into 9 twice with a remainder of 1. 4 won't go into 14, so 4 does not go into 94. But they're all even, so I know that I can factor out a 2. So it's going to be 2 times 2x squared minus 20x plus half of 94 is 47 equals 0. There's step 1. Okay, so that's what you should always try first. Always, always, always step 1, look for greatest common factor. But now that I have done this, now I look at this and I want to find products of 2 times 47, which is 94, that add up to 20. So factors of 94 that add up to 20, we could check it, but I'm just going to tell you right now there aren't any. So there's no way to factor this by looking for factors of c that add up to b. So instead of doing that, I'm going to complete the square. So what I'm trying to explain to you here, I didn't make a mistake by doing this. You should always try GCF first, but since it's not going to work, we will try completing the square. So in completing the square, we're going to take the first term outside and then put our x terms inside. I'm leaving a space for the coefficient of x, and I'm leaving a space for the completing of the square, and I'm putting the constant outside, like so. Okay, so now 4 times x squared is 4x squared, and 4 times what is negative 40? Okay, so now I know that this is 10. So 4 times 10 is 40. All right, so now I take that 10, which is my b, off to the side here, and divide it by 2, and I get 5. And I'm going to put that in parentheses and show it as squared. I know that's 25, but I want to use this, so I'm going to, in purple, write plus 5 squared. And since I have a 4 times a 5 squared, over here I'm going to subtract 4 times a 5 squared. Okay, but I'm going to make one change to that. I don't want it on the other side with my 0. I want it on the same side of the equation, opposite sign. So I'm going to put minus 4 times 5 squared and have it still equal to 0. I could do it either way, but I would prefer to leave this on this side because I want it equal to 0 for when I factor at the end. Okay, so now I have 4 parentheses x minus 5 squared. Okay, this sign right here is always going to match here because a negative times a negative is positive here. So I have 4 times x minus 5 quantity squared will give me this. I have a plus 94 minus 5 squared is 25 times 4 is 100 equals 0. And then I'm simplifying that. Oops. So it's 4 parentheses x minus 5 quantity squared, and 94 minus 100 is minus 6. Okay. So now I'm going to get my perfect square. Actually, I want to solve for x now. Okay, so I'm going to add 6 to both sides. And that's going to give me 4 times x minus 5 squared equals 6. Divide both sides by 4. And these cancel. And I get x minus 5 quantity squared equals 6 over 4. Okay. I'm now going to take the square root of both sides because I want to get rid of that squared. And I get x minus 5 equals the square root of 6 over 4. And I should have that radical come all the way down, show that fraction all inside. Okay. Moving over to here. I'm now going to add 5 to both sides. So it's going to be x minus 5 plus 5 equals, and I'm going to simplify this as well. The square root of 6 over the square root of 4 would be the square root of 6 over 2 with the radical not covering the denominator. Okay, so then I have plus 5 over here. So I'm going to end up with x equals, and I want to put my constant first, and it's plus or minus, remember, plus or minus the square root of 6 over 2. So my answer is x equals 5 minus the square root of 6 divided by 2, or x equals 5 plus the square root of 6 over 2. And there is solving by completing the square. Now earlier I did show putting this piece here, this right here, over here as a plus as well, added to this side and this side. You can do it either way. I'm not going to take time in this video, but if I showed you the other way, you would get the same answer. All right, here's number 1 exercise. So pause the video, see if you can do this, and then come back and see how you did. All right, so here we go. So I have x squared minus 2x equals 12. Leave the constant on the right. I'm going to complete the square on the left. X squared minus 2x. Now remember, I'm taking that minus 2, which is my b, taking half of it, which equals negative 1, and I'm going to square it, which gives me 1. So I'm going to write x squared minus 2x plus 1 equals 12 plus 1. So if I add 1 to the left, I have to add 1 to the right. Okay, so now this is a perfect square. It's x minus 1 quantity squared. It's this, remember? And if I FOIL that or distribute it, then you will see it does equal that. And then that equals 13. In order to solve this now, I take the square root of both sides. And that will give me x minus 1 equals the square root, and it's positive or negative 13. Add 1 to both sides, and I get x equals 1 plus or minus the square root of 13. And that is the answer. Okay, on to page 3. These are still exercises, so you should pause the video and see if you can do them on your own. And so here we go. Let's check your answers. So we have 1/2 r squared minus 6r equals 2. So the first thing I'm going to do is factor out that half. And I'm going to put my r squared minus some r, leave a space, equals 2. Now I'm going to do this one differently. I'm going to do it with adding the same thing to both sides. I didn't do that on number 1, but I will do it here. So you have to ask yourself, 1/2 of what is 6? And the answer is 12. So 1/2 times r squared is 1/2 r squared. 1/2 times a negative 12 is negative 6r. And so now I take that negative 12, divide it by 2, and I get negative 6, and I square that and get 36. But I'm going to use this value here. I'm going to put minus 6. Actually, it's plus. That's always positive. So let me do that correctly. It's always plus. And I'm going to put negative 6 squared here. So over here, I'm going to do the same. I'm going to add 1/2 times negative 6 squared to this side. Since I've added it to this side, I need to add it over here. Add to the left, add to the right, it's still equal. Okay, so now I have 1/2 r minus my b divided by 2 squared, and that's a perfect square, right? That'll give me this, equals 2 plus 1/2 times negative 6 squared. Well, negative 6 squared is 36. 36 times a half of 36 is 18. 18 plus 2 is 20. Okay, I just did that all in one step. 2 plus 18 is 20. Now I want to solve this for r, so I'm going to multiply both sides by 2 over 1, or simply 2. And that's going to cancel these, and I get r minus 6 squared equals 40. Okay, we're almost done. Take the square root of both sides. And remember, that's plus or minus. And we're going to get r minus 6 equals plus or minus the square root of 40. All right, so now when I move this 6 over to the other side, it's going to go in front here. So we're going to get r equals 6, because I added 6 to both sides. I'll show it here. And when I do that, I get r equals 6 plus or minus the square root of 40. Okay? This can be reduced. So how about I do that? Do you remember how to reduce a radical? Here's how I show the students. I take 40 and I do a factor tree. And I say 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. Since my radicand, or my index is 2, that's how many terms I need out inside to be 1 outside. So 2 times 2 is 4, and the square root of 4 is 2. So this would end up being r equals 6 plus or minus. This 2 will come outside of the radical, and what is not a pair has to stay in, and that's multiplication. So that's the square root of 10. Okay, so this is an answer, and this is the answer with a simplified radical. Okay, number 3. 2p squared plus 8p equals 7. First thing I'm going to do is factor out a 2. So it's 2 times p squared plus 4p equals 7. Okay, so now I'm going to take this 2 and I'm going to complete the square inside here. So it's p squared plus 4p. And I'm still going to do this off to the side, but once you get the hang of this, it's quicker. Okay, half of 4 is 2. 2 squared is 4. So 4 divided by 2 is 2. Squared equals 4. So I'm going to put p squared plus 4p plus 4. And I'm still going to do it this way. Plus 2 squared, which is 4, equals, and let me change the color of this 2 out here as well, just so you see that that is 2 times 2 squared, or 2 times 4, which is 8. And then on the other side I have a 7, and since I added 2 times 2 squared, I have to add 2 times 2 squared on this side. Let's do it that way. So this and this are added to both sides. Okay. All right, so let's finish this. This is going to be 2, and this is going to be p plus 2 quantity squared equals 2 squared is 4 times 2 is 8. 7 plus 8 is 15. So I have 2 times p plus 2 squared equals 15. I'm going to divide both sides by 2. This is going to cancel these 2's, and I get p plus 2 quantity squared equals 15 over 2. Okay. Move over to here to finish this. I'm going to take the square root of both of these, and I'm going to get p plus 2 equals, plus or minus, the square root of 15 over 2. I'm going to subtract 2 from both sides, and that is going to give me p equals, and I always put my constant first and then my radical after because of the plus or minus. And I want the square root of 15 over 2. And there's my answer. Okay. Okay, here's number 4. I have a 2, I have a 3, I have a -5. There is no greatest common factor. I cannot factor anything out of that, so I'm just going to factor out that first term of 2. So I'm going to put a 2 here, and then I'm going to use a bracket here, and I'm going to put my y squared plus, leave a space, some y, and then close the parentheses, leave a space for what I'm adding. Actually, let me move this over a little further. I wrote it too quick, so it's connected. I just want this, I don't want to crowd myself. And then -5 outside equals 4. Okay, so 2 times y squared is 2y squared. 2 times what is 3? Okay, that may seem a little difficult to you, but all you do is take this number and put that under it. So it's 3 halves. Because think of that as 2 over 1, the 2's cancel, and you get 3 over 1, or 3. So 2 times 3 halves, or 6 halves, is 3. All right, so there's my b. So off to the side here, I'm going to write 3 over 2, and I'm going to divide it by 2. Think of that as 2 over 1. Remember your rules from middle school. 3 halves divided by 2 over 1 is the same as 3 halves times 1 half, which is 3/4. And I'm going to square that. Okay, it's 9/16, but I'm going to leave it like this. So it's plus 3 over 4 squared. So since I took 2, and actually I don't want this 3 halves red, because that's not changed. 2 times 3 halves is 3. What I've changed in this completing the square is this 2 times this, and since I did that over there, I have to do it over here as well. So it's going to be plus 2 times 3/4 squared on the right side as well. Okay, now we're cooking with gas. So now we have 2 parentheses y, and remember our middle term is our b is 3/4, so it's this sign right here plus b divided by 2 quantity squared. All right, so that's this. We have a minus 5 equals, well, 3/4 squared is 9/16. So I have 4 plus 2 and 9/16. So be careful with this. So over here I'm going to write 4 plus 2 and 9/16. And then I'm going to make this improper. 16 times 2 is 32, plus 9 is 41 over 16. And I want this to have a denominator of 16. So 16 times 4 is 64. So 4 is 64/16. So 64 plus 41 is 105 over 16. Okay, a little bit of a mistake there. I was thinking this is multiplied, and I was just thinking it's 2 and, which is plus. So let me fix this. We can think of this another way. 3/4 is 9/16 times 2. Let's do that part first. So this is going to be 4 plus 2 times 9/16, and the 2 will make the 16 8. So it's 9/8. 4 plus 9/8. So I have 2 y plus 3/4. Okay. Squared minus 5 equals. So now I have 4, but I need a denominator of 8. So 32 over 8 is 4, plus 9 over 8. Okay. So I have 2 y plus 3/4 squared minus 5 equals 41 over 8. Okay, but now I need to move this 5 over here. I could have done it first, probably would have been easier, but anyway, if I add 5 to both sides, 5 is 40 over 8. Right? 40 divided by 8 is 5. So if I add 5 to this side and I add 5 to this side, I get 2 y plus 3/4 squared equals 81/8. Now I'm going to divide by 2. And remember, dividing by 2 is the same as multiplying by a half. These cancel, and I get y plus 3/4 squared equals 81 over 16. Okay, getting closer. Now I take the square root of both sides, and I get y plus 3 over 4 equals Now the square root of 81 is 9. These are perfect squares, which makes it nice. The square root of 81 is 9, so it's plus or minus 9 over 4. So now I'm going to move that 3/4 over here. So y equals negative 3/4 plus 9/4, or y equals negative 3/4 minus 9/4. So this is going to give me 6/4, which equals 3/2. And this is going to give me negative 12/4, which equals, sorry about those 4s, they always snap when I'm writing with this pad. And that equals negative 3. So my answer is 3/2 or negative 3. Okay, that brings us to the last page and our end of our lesson. So review this lesson summary and go do your problem set.